This is for 2.8, number 18, which is on page 195. They actually give me a picture for this one, so I kind of made that picture. It says, a boat is pulled by a winch on a dock, and the winch is 12 feet above the deck of the boat. See figure, so this is our 12 here. It pulls the rope at a rate of 4 feet per second. So it's pulling this direction 4 feet per second because that's where the rope is attached. Find the speed of the boat when 13 feet of rope is out. What happens to the speed of the boat as it gets closer and closer to the dock? Okay, so we're given that this is 13 just at that instant, right? I'm going to take the 13 out for the moment and put this as like an X. Because isn't that changing as this is being pulled? So it's not always 13. It's 13 at the spot I'm looking for my answer for, but it's not 13 the entire time, okay? So let's go ahead and write what we know. What's this 4 going to be? dx dt. So what's known is that dx dt is equal to 4. You could have it 4, you could have it negative 4. I'm not going to get too caught up in that, okay? Why is this x? Because it's changing. It's 13 at the spot I'm looking for. So what we're trying to find, what are we trying to find here? Find the speed of the boat when 13 feet of rope is out. So isn't the speed of the boat like this, like how much it's going this direction? So I'm going to call this y. Is that okay? So what am I trying to find? dy dt. When x is equal to what? 13. And if x is 13, do I know what y equals? I could find it, right? If x is 13, what's y going to be? Go ahead and figure that out. Do we get 5? Okay, so y is 5 at that instant. What equation do you think I'm going to use to relate these? Pythagorean theorem. So go ahead and give it a try now. See what you come up with there, and then we'll do it together in a minute. Okay, so we should have had Pythagorean theorem here. We do y squared plus 12 squared equals x squared. And the reason I have variables for these is because they're changing. Okay, the 12 does not change. That height doesn't change. This is changing as the rope's getting pulled, and this is changing as the rope's getting pulled. So that's why there's variables there. Now with this, I take the derivative with respect to time. So this is 2y dy dt plus 0, because this is just a constant there, equals 2x dx dt. And then we can plug in the pieces. So I know dx dt is 4, so I'm going to plug 4 in here. I know x is 13 at the spot I'm looking for, and I know y is 5. So if I plug in all those pieces, I have 10 dy dt equals 2 times 13 times 4. What's that? What was it? 104. And then divide by 10, and I get dy dt is 10.4. It's not feet. What's my y in? My y is in feet, but I need the y per time, so feet per second. Okay, it's a rate you have to remember. Does that make sense? Any questions on any of those steps? Number 12, they give us a C and an R here, so let's read it. It says, a company that manufactures pet toys calculates that its cost and revenue can be modeled by these equations. So we have the cost is the C, the revenue is the R there, where X is the number of toys produced in 1 week. So I'm just going to write that in case it's relevant. Number of toys per week, right? Okay. If production in one particular week is 5,000 toys, so what would that 5,000 be? Doesn't it say 5,000 toys? Okay. So my X would be 5,000 for that piece, right? I'm just going to write that. And is increasing at a rate of 250 toys per week. What's that tell me? dx dt, right? Because the number of toys is increasing by 250. And I'll write this out nicer over here in a second. Find the rate at which the cost is changing. So what is the rate at which the cost is changing? What would I have to do? I'm trying to find what? dc dt. So find dc dt. When dx dt is 250 and x is equal to 5,000. Okay, so you know these two pieces here. You're trying to find dc dt. So what do I have to do to find dc dt? I have to take the derivative of this. So the derivative of c is just dc dt. The derivative of 75,000, 0. The derivative of this, 1.05 times dx dt, right? So do I even need the 5,000 in this case? No. So go ahead and multiply those, see what you get. So what do I get? Yeah, $262.50. So my dc dt is $262.50. And what's the actual label for this? It's not just dollars. Dollars per week, right? So that's, if you want to put the dollars here and write per week, that's fine. Or if you want to put dollars per week in the back and just not put the dollar sign. Okay, but the week is your time there, so. Okay, let's try part B now. So part B is saying the rate at which the revenue is changing. Can you guys find that now? We should be able to, so go ahead and do part B on your own. That shouldn't be an issue. And then we'll look at C in a minute here. Okay, guys, when you do the derivative of this, I know some people are having issues with the back one. You could use the quotient rule, or you can just write it as 1 over 25 x squared. Isn't that easier to take the derivative of? Just pull the 2 down front. It'll be 2 25ths x to the first, and then dx dt in the back. Okay. Now for part C, I'm going to have you guys do that one on your own also. It says the rate at which the profit is changing. How do I find profit? Revenue minus costs. Now can you find it? So you take your revenue function, subtract your cost function, and take the derivative. Okay, so I'll have you finish those. I'll come around and check your answers.